Lesson 61 for geometry, determining if a quadrilateral is a parallelogram. I'll have several identifying parallelograms throughout the lesson, so pay attention, okay? If both pairs of parallel sides of a quadrilateral are congruent, then the quadrilateral is a parallelogram. Parallelogram just means that the opposite sides are parallel to each other, okay? So this is a parallelogram because segment MN and segment PQ are congruent to each other, which is denoted by this symbol. And segment MP and segment NQ are congruent to each other, denoted by the two tick marks, okay? Let's move to our first example. It says, in quadrilateral WXYZ, segment WX is parallel to segment ZY, and angle Z is congruent to angle X. Is this a parallelogram? So this one, they tell about parallel sides, not congruent, okay? But we need to decide if this is a parallelogram. So you're gonna have to think back a little bit and use some things that you've learned in the past, okay? So I drew this line right here from W to Y. So now I have a line segment right here, segment WY, to create two triangles, because you can cut a parallelogram into two triangles, okay? There is a theorem about when you cut a parallelogram in half, it's two congruent triangles, but I want to be able to prove this to you, okay? So we have this triangle right here, which is WXY, and then the triangle here, which is WZY, okay? Two triangles. We don't know if they're congruent yet, okay? It says that WX and ZY are parallel to each other. Since they're parallel to each other, you can use or act like it's two parallel lines that were cut through by, act like WY right here is a transversal. So just kind of extend them past to where they are. Act like WX and ZY get extended, they're pulled out, and they're parallel to each other. And then you have a transversal, which is WY, that's cutting through the two parallel lines. Using that, you can know, because they're being cut by a transversal, you know that alternate interior angles are congruent, okay? These angle Z and angle X are congruent, which they told us, but we know that because they're alternate interior angles, meaning they're on opposite sides of the transversal and they're on the inside of this line right here, okay? Now, segment WY, this guy right here that I created a transversal, it's congruent to itself, right? When you're looking at the triangle, WY on the yellow triangle is going to be the same length as WY on the orange triangle. So you can know that WY, segment WY, is congruent to itself because it's the same side on the triangle. They're butted up right next to each other. Okay, that's the reflexive property of congruence. So we can say that these two triangles, WZY, wow, sorry guys, that looks like an A. Triangle WZY, we can say that it's congruent to triangle WXY. And you can say that by angle, side theorem. This is how we know. Angle, side is how we know. They have a side that is congruent to each other and an angle that's, two angles that are congruent to each other, okay? Next, by CP/CTC, congruent parts of congruent triangles are congruent, okay? By CP/CTC, if you don't know that, it means congruent parts of congruent triangles are congruent. You can know that WX is congruent to ZY, this segment, which is what they're asking us to prove. These two are not only parallel, but they're also congruent to each other. Since they're congruent to each other, then these opposite sides are also going to be congruent. So you can put a little congruent guy right there, and that means that these two guys are going to be congruent, okay? WZ is going to be congruent to XY. So that means we have two pairs of parallel sides. Yes, this is a parallelogram. WXYZ is a parallelogram. That's such a long word. Okay, next, identifying parallelograms. If both pairs of opposite angles of a quadrilateral are congruent, then it's a parallelogram. So now on this first one, we were talking about the sides. If the opposite sides are parallel, it's a parallelogram. Now if the opposite angles are congruent, then it's a parallelogram. So angle S and angle U are congruent to each other. It's denoted by this little like half moon. And angle V and angle T are congruent to each other, denoted by the double half moon because it's our second angle that's congruent. So STUV, or STUV, is a parallelogram. Next example says, in quadrilateral PQRS, this segment PQ is congruent to segment SR, meaning they're equal to each other. And look, it's denoted with this little tick mark. They ask us if this is a parallelogram PQRS. What you're going to do, excuse me, you're going to make these guys equal to each other. We want to solve for x because look, this side PQ is 3x plus 2 is the length of the side. The length of this side, SR, is 5x minus 38. And then they have the angles here. It has an x, 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 x. So to find the length of all the sides and all of the angles, you have to solve for x. The only way we can solve for x is because we know that segment PQ and segment SR are congruent. Okay, so let's set up 3x plus 2 equals 5x minus 38. And we'll solve for x. We'll be able to solve for everything else. Okay, I'm going to subtract 3x from both sides to combine the like terms. On the left of the equal sign, I have 2 equals 5x minus 3x is 2x minus 38. I'm going to add 38 to both sides to get x by itself. 2 plus 38 is 40 equals 2x. Negative 38 plus 38 is 0. To solve for x, you divide both sides by 2. 2's cancel here. X equals 40 divided by 2, which is 20. X equals 20. So we know what x is. Now we can find the measure of these angles, and we'll be able to tell if it's a parallelogram because our last, it wasn't a theorem, but the last thing that told us how to identify parallelograms is if the opposite angles, if these two angles are congruent and these two angles are congruent, it's a parallelogram. We can't use the sides because we only know one pair of congruent sides. We don't know if these two are congruent or not. So plug x in here. So for angle P, it's 6 times x, which in this case is 20. 6 times 20 is 120. Okay, let's see if this angle right here, angle R, is 120 degrees. Plug x in, which is 20. So 5 times 20 plus 20. Okay, 5 times 20 is 100 plus 20, 120. Ooh, we're looking pretty good here. These opposite angles are congruent to each other. So you can put the little symbol here, the half moon. Now let's find angle Q. 5x minus 40. So 5 times 20 minus 40. 5 times 20 is 100. 100 minus 40 is 60. Okay, and then angle S, its opposite angle Q, is 3 times x, so 3 times 20, which is 60. These two angles are congruent. They both equal 60 degrees. You can draw your little symbol that says they're congruent. So yes, you can just write yes. PQRS is a parallelogram because the opposite angles are congruent to each other. Next, identifying parallelograms. It says, if one pair of opposite sides of a quadrilateral is both parallel and congruent, then the quadrilateral is a parallelogram. So if you have a pair of opposite sides that are parallel and congruent, you don't have to worry about these other sides. Just if AB and DC are opposite of each other and they're parallel to each other and congruent to each other, then it's a then it's a parallelogram. So here's our quadrilateral, JKLM. It says angle J and angle M are supplementary and segment JK is congruent to segment ML. Is this a parallelogram? Supplementary, if you don't know what supplementary means, it means that if you add these two angles together, angle J and angle M, it's going to add up to 180 degrees. So 1 plus 4, these two angles, angle J, I'm going to say, plus angle M, they're supplementary, so they're going to equal 180 degrees. Well, we don't know what angle 1 and angle 4 equal. It doesn't tell us. But because they're supplementary, then you can say the same side interior angles theorem. You can use that and say that JK and ML, these guys are congruent. Or parallel, I'm sorry. Because of this same side interior angle theorem. Again, it's like if you were to extend the lines, and these guys right here got extended. Okay, these two are congruent and parallel. So these guys are the transversals because angle 1 and angle 4, or angle J and angle M, are on the same side of the transversal and they're on the inside. So it's like they're in between this line and the transversal. They're both on the same side and interior angles. Then we can say that JK and ML are also parallel. So yes, JKLM is a parallelogram. Okay, next, identifying parallelograms. It's our last one. It says if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram. QRST. Bisect means to cut in half. So the diagonals, they go from one angle to the other angle, the opposite angle. So Q and S. This line right here is a diagonal, and then TR is a diagonal. Cuts straight through the angles, the opposite angles. This says if these two diagonals bisect each other, bisect means to cut in half. If they cut each other in half, then it's a parallelogram. So T to here, the center, and the center to R is congruent to each other. So QRST is a parallelogram. The last example says in quadrilateral RSTU, segment RU is congruent to segment ST. So you can put it's congruent with the tick mark right here. Is RSTU a parallelogram? Excuse me. So we know that these two guys are congruent. To be able to figure out if this whole thing is a parallelogram, what we need to do is we need to solve for x first, okay? So, I'm sorry, I didn't write all of the numbers on the outside. 9, I was trying to figure out how we were going to solve. And 2x plus 3. So the length of RU is 9, and the length of ST is 2x plus 3. Okay, we can say that they're equal to each other because right here it tells us that those sides are congruent. Solve for x by subtracting 3 from both sides. 9 minus 3 is 6. And you have 2x on the right. Solve for x by dividing by 2. 6 divided by 2 is 3, so x equals 3. Now, we're going to substitute x in here so we can find the length of these lines right here. The diagonals, they're cut in half right here. If they are congruent, so if RV is congruent to VT, then this is a parallelogram. So RV, which is the length from here to V, and then from V to T, okay? RV is congruent to VT. Let's see, I'm not sure. We're gonna plug X in here. So we have x plus 3 for RV and 2x for VT. Okay, let's figure out, we know x is 3, we'll plug that in and see if these two segments are congruent. 3 plus 3 is 6. 2 times 3 is 6. So yes, they are congruent to each other. RV, this length, the orange length, is congruent to the yellow length. That's because this diagonal got cut in half. These two are probably also the same. Let's see the UV to VS. Let's see if those lengths are the same. Okay, UV, segment UV, see if it's congruent to segment VS. UV, the length right here is 3x minus 2. We aren't sure. And then VS from here to here is 4x minus 5. We know what x is, it's 3, we'll plug that in. Three times 3 is 9. 9 minus 2 is 7. 4 times 3 is 12. 12 minus 5 is also 7. So yes, both UV is congruent to VS. You can draw a little tick mark. And then RV is congruent to VT. Draw 2 tick marks. Okay, so yes, it's a parallelogram. RSTU is a parallelogram. Your homework for lesson 61 is A through D, and it'll be on Plus Portals.